Good afternoon. My name is Salehi. Today I'm going to walk you through my research on pressure-based gait recognition. Our research explores the application of feature learning network in person identification. As an introduction, let's start with gait recognition, which is analyzed both physical and behavioral characteristics. It studies how individuals move their body during walking, capturing their unique movement patterns. Various modalities such as computer vision, wearables, and pressure sensors can be used to measure gait patterns. However, wearable sensor installation and calibration is a tedious task, and video-based approaches are both affected by environmental conditions and can be prone to racial and gender biases. Moreover, privacy concerns arise with video-based methods. At the University of New Brunswick, we are exploring promising alternative in the form of floor sensor-based gait recognition. Analyzing foot pressure patterns during regular gait can overcome issues associated with video-based approaches, ensuring reliable identification even in a complete darkness. Here at the Health and Technology Lab at the University of New Brunswick, we have installed 12 pressure-sensitive step-scan tile and 7 video cameras, approved by our Research Ethics Board. Our goal is to collect as many as 200 subjects by the end of this summer. Floor sensor-based gait recognition gives us valuable insights for applications like health monitoring, rehabilitation, fall detection, and access control. In this research, we've explored pressure gait application in person authentication, which is the process of verifying a person's identity. Here you can see the architecture of convolutional neural networks, or CNN. Different variations of CNN have been implemented to analyze gait data. Notably, previous research work discovered that the performance of CNNs failed when the sample size was reduced. This limitation is particularly concerning, as collecting a large number of training samples per user is often impractical in real-world scenarios. This study therefore investigates the performance of various feature extraction methods, both traditional machine learning and deep learning approaches, to improve the accuracy and gait recognition. Feature learning networks integrate traditional feature extraction methods within CNN framework, providing a more structured approach that requires fewer training samples. Surprisingly, these lightweight networks yield a state-of-the-art result, surpassing other deep learning networks and traditional machine learning methods in many classification tasks, such as cancer detection, face recognition, and medical signal analysis. For our experimental setting, we implemented various machine learning feature extraction and feature learning networks. We compared these networks against the baseline of traditional feature extraction methods. The inspiration of these networks comes from conventional feature extraction approaches where techniques like DWT, DCT, ICA, and PCA are employed. These methods serve as kernel function within the feature learning network. By analyzing their effectiveness, we can gain insights into the strengths and limitations of different feature learning networks to later on develop our own model. After extracting the features, we classify them using a SVM technique based on RBF kernel. We have evaluated the models using holdout cross-validation by splitting data into 80-20 for train and test. For performance evaluation metrics, FAR, FRR, and the balance accuracy were recorded. Balance accuracy combines FAR and FRR, giving equal weight to both and offer a holistic measure of system performance. Balance accuracy is calculated as follows. Here, we visualize the filters associated with feature learning network. It's interesting to note that the SCATNet and DCTNet are prefix filtered to focus on specific frequencies and features. At the same time, ICNet and PCNet utilize the eigenvalues of the input data for adaptive filtering. In this slide, we visualize the features extracted from different layers of feature learning networks. As you can see, the extracted features exhibit different representation of food pressure profile and highlight the pressure in different parts of the food. These visualizations provide insights into learned representations and the distinctive capability of each network. The box plot of our results for 97 subjects revealed that the feature learning network significantly outperformed the conventional feature extraction methods. As it's shown in the figure of specific pairs of conventional and feature learning methods, individually, we observe, however, that DCTNet didn't provide an improvement over its counterpart, DCT. This result aligns with the previous research where DCTNet exhibited poor performance when the input image did not exhibit high local coloration. Here's the box plot demonstrating the performance of different feature learning networks that identifies PCANet with the best verification performance, achieving a balanced accuracy of 92.2%. Despite its simplicity and lacking more advanced components present in conventional CNNs, PCANet proved to be highly competitive with a small amount of data was available for model training. Additionally, variation of PCANet such as PCANet Plus and PCANet version 2 have shown potential for further improvement and should be investigated in future studies. The application of feature learning network with pressure-based gait recognition holds promise for a wide range of applications, from airport security checkpoint to cultural landmark and residential access system. This system could open doors, both literally or metaphorically, while overcoming limitations of vision-based biometric approaches. But our research doesn't end here. There is still much to explore. Our ongoing research seeks to enhance the robustness of gait recognition across different populations in real-world scenarios. Further validation of the performance of feature learning network is being explored, pushing the boundaries of what is possible in floor sensor-based gait recognition. I'd like to acknowledge that our project was supported by NBIF, NCOA, and NSERC. Thank you so much for your attention.